Children, it is a continuation of the chapter Lines and Angles. You already learnt about the transversal of two lines and also different types of angles made by the transversal of two lines. Now, let us discuss about the nature of the angles made by the transversal of parallel lines. That is, how the corresponding angles are, how the alternate angles are, and how the interior angles on the same side of the transversals are. Here, you do one activity. You know that the root line of your notebook are parallel to each other, and you take a root line paper and with ruler and pencil draw two parallel lines along any two of these lines and a transversal to intersect, and also draw the transversal to intersect the two lines at different points. Now here let us have the parallel lines. You know, the parallel lines are lines which do not intersect each other even if they produced on both the sides infinitely. Here we have drawn the parallel lines M and N, and L is a transversal. As usual, there are 8 angles and you measure all the 8 angles. Here, by measuring, we got that only 2 types of measurement here we got. That is angle 1, angle 3, angle 5 and angle 7. All these are equal and their measurement is 110 degree we got here. And next angle 2, angle 4, angle 6 and angle 8. Angle 2, angle 4, angle 6 and angle 8, they are of measurement 70 degree. They are equal. All these 4 angles are equal and their measurement is 70 degree. In this way we got only 2 measurements here, 110 degree and 70 degree. And now let us discuss about the corresponding angles. Here you know that, here let us take the corresponding angles. You know that here you got only 2 types of measurements, 110, 110, 70, 70. That is the measurement of all the angles here we got. That is, here you know that if you measure the corresponding angles, means if you consider the corresponding angles, here which are the corresponding angles? Angle 1 and angle 5, they are having same measurement. Angle 3 and angle 7 are also having same measurement. So what you can conclude here? Corresponding angles. Angle 1 is equals to angle 5 and angle 2 is equals to angle 6 and also angle 4 is equals to angle 8 and angle 3 is equals to angle 7. Here angle 1 is equals to angle 5, that is 110 degree, and angle 2 is equals to angle 6, they are 70 degree, and angle 4 is equals to angle 8, they are 70 degree, and angle, that is angle 3 is equals to angle 7. Angle 3 and angle 7, they are 110 degree here. Angle 3 and angle 7, they are 110 degree. In this way, what you can conclude here? When a transversal intersect parallel lines, the pair of corresponding angles are equal. That is, when a transversal intersect parallel lines, pairs of corresponding angles are equal. Here, you know that 1 is equals to 5. 1 is equals to 5. 2 is equals to 6. That is 2 is equals to 6. And 4 is equals to 8. 4 is equals to 8. And 3 is equals to 7. That is 3 is equals to 7. So, here what you can conclude? Corresponding angles are equal. corresponding angles are equal. The corresponding angles made by the transversal of parallel lines are equal. That is, there is an axiom related to the corresponding angles made by the transversal of parallel lines, and that axiom is called corresponding angles axiom. And that is, if a transversal intersect two parallel lines, then each pair of corresponding angles is equal. So, what is the corresponding angle axiom? That is, corresponding angle axiom is, if a transversal intersect two parallel lines, then each pair of corresponding angles are equal. Then each pair of corresponding angles are equal. That is the corresponding angle and corresponding angles axiom. So that is, angle 1 is equals to angle 5, angle 2 is equals to angle 6. They are above the lines here, and also angle 3 is equals to angle 7, angle 4 is equals to angle 8. So you got 4 pairs of corresponding angles are equal. According to the corresponding angles axiom, you concluded that if a transversal intersect two parallel lines, then each pair of corresponding angles are equal. Next, converse of corresponding angle axiom. Converse of corresponding angles axiom. That is, here you draw two lines and also draw the transversal, and you don't know whether that lines are parallel or not. Now you measure the corresponding angles. If they are equal means, then what you can conclude? That lines are parallel to each other. For example, here M and N are the M and L are the two lines, and you take here A is a transversal. A is a transversal. Now you measure all the angles made by the transversal of these two lines. Then if the corresponding angles are equal, if angle 1 is equals to angle 5, 2 is equals to angle 6, angle 4 is equals to angle 8, angle 3 is equals to angle 7, then what you can conclude? Then the line M is parallel to L, means the lines are parallel to each other. So what the converse of corresponding angle axiom says? If a transversal intersect two lines such that a pair of corresponding angles is equal, then the two lines are parallel to each other. Corresponding angles axiom says that if a transversal intersect parallel lines, corresponding angles are equal. Converse of corresponding angle axiom says that if the corresponding angles made by the transversal of two lines are equal, then that two lines are parallel to each other. So here, know that here, if in the figure, if measure all the angles, if angle 1 is equals to angle 5, one pair enough here, and angle 2 is equals to angle 6, and angle 4 is equals to angle 8, angle 3 is equals to angle 7. To verify this, you do an activity. Draw a line AD and mark points B and C on it. At B and C, construct angle ABL and angle BCM, which are equals to each other. Construct equal angles at B. Produce the line LB and MC to verify that whether they are intersecting or not. So you produce both the lines here. You may observe that these two lines do not intersect each other, and also you can draw common perpendicular to these two lines. Common perpendicular to the line LO and MP, and here you got the result that when the corresponding angles are equal means the lines are parallel to each other. Here angle ABL and angle BCM becomes they are the corresponding angles made by the transversal AD. As they are equal, here you concluded that LO is parallel to MP. So you got the verification here. When the corresponding angles made by the transversal of two lines are equal, then those two lines are parallel to each other. Here what you got? Angle ABL is equals to angle BCM and LO is parallel to MP. LO is parallel to MP, and here AD becomes the AD is the transversal intersecting LO at B and MP at C. So here you got the verification of the converse of corresponding angle axiom. Now let us verify the nature of the alternate angles, that is nature of the alternate interior angles made by the transversal of parallel lines. Here already we got the measurement of all the angles made by the transversal of parallel lines M and N. And here you got the measurement. You got the measurement of 70 degree and 70 degree for one pair of alternate interior angles, and also 110 degree and 110 degree for the measurement of another pair of alternate interior angles. Therefore, we can say that if a transversal intersect two parallel lines, then each pair of alternate angles are equal. That is the alternate angles theorem here. What the alternate angles theorem says? If a transversal intersects two parallel lines, then each pair of alternate angles are equal. Here we got in this figure, you know that it is taken that AB is parallel to CD. Here AB is parallel to CD and XY is a transversal intersect AB at L and CD at M here. Transversal XY intersects AB at L and CD at M. Then here let us verify the alternate angles and also let us prove it logically. The pairs of alternate angles are equal here. How it is? Here you know that angle XLB is equals to angle ALB. So first you take angle XLB is equals to angle ALM it is. Angle XLB is equals to angle ALM. You know the reason? They are vertically opposite angles. Naturally they are equal. And also you know that here angle XLB is equals to angle LMD. Angle XLB is equals to angle LMD. Reason? That is, they are the corresponding angles. You know that corresponding angles made by the transversal of parallel lines are equal. That is the corresponding angle axiom. So you write what they are: corresponding angles. They are the corresponding angle made by the transversal of parallel lines. So from first and second, what you can write here? From first and second. From first and second, here you know that in both the relation LHS are same, so there must be RHS must be equal here. So therefore you can write ALM ALM is equals to what? LMD. They are nothing but it is a pair of alternate interior angle. You got one result here. Next, to prove another result, you have here, again you take this pair here. That is angle ALX. ALX is equals to which angle? You know that. That is BLM it is. That is angle BLM. Same reason you can give, they are vertically opposite angles here. And also angle ALX is equals to, its corresponding angle is CML or LMC. LMC. Here ALX and LMC, it is one pair of corresponding angle. So they must be equal. You write here it is corresponding angles. Again he got the same thing in the LHS. There must be equality in the RHS. So RHS, which are what is there in the RHS both the side, that is angle BLM must be equals to angle LMC. So you got second pair of alternate interior angles which are equal here. So in this way you got the verification, and logically you proved that if a transversal intersect two parallel lines, then each pair of alternate angles are equal. Now the converse of alternate angles theorem. The statement says, if a transversal intersect two lines in such a way that a pair of alternate interior angles is equal, then the two lines are parallel. Here in this figure there are two lines and L is a transversal, and if you got the measurement of the alternate angles, they are equal. So if you got alternate angles are equal, then you can say that that line M is parallel to N. So in the figure, if angle 4 is equals to angle 6 and also angle 3 is equals to angle 5, then what you can say? The line M is parallel to L. If alternate angles are equal, then those two lines are equal. So that is the converse of alternate angles theorem. Converse of alternate angles theorem. Now let us verify the nature of the interior angles on the same side of the transversal of parallel lines. Here you got the measurement, and see here these two. You got the measurement 70 and 110 and verify their sum here. You know that 110 plus 70 is 180 degree. Here also 110 and 70, their sum is 180 degree. So here you got angle 4 plus angle 5, which are the interior angles on the same side of the transversal. Their sum you got 180 degree here. And also angle 3 plus angle 6, that is the other pair of interior angles on the other same side of the transversal. Their sum is also here 110 plus 70, that is also 180 degree. So here what you can conclude, when a transversal intersect parallel lines, then the sum of interior angles on the same side of the transversal is 180 degree. It means the interior angles on the same side of the transversal of parallel lines are supplementary. So they are supplementary, you got here. It is nothing but interior angles theorem. What is the statement of the interior angles theorem? If a transversal intersects two parallel lines, then each pair of interior angles on the same side of the transversal is supplementary. Means their sum is 180 degree. And also converse of interior angles theorem, it says that if a transversal intersects two lines such that a pair of interior angles on the same side of the transversal is supplementary, then the two lines are parallel. Here in the figure, if angle 4 plus angle 5 is equals to 180 degree, and also angle 3 plus angle 6 is equals to 180 degree, then what? Then the line M is parallel to L. That is, if the interior angles on the same side of the transversal of parallel lines are supplementary, then those two lines are parallel to each other. That is the converse of the interior angles theorem. In this way, you got the spatial nature of the angles made by the transversal of parallel lines. Now let us discuss about the nature of the lines parallel to the same line. Here there are three lines. They are in such a way that the line M is parallel to L, and the line N is also parallel to L. Now what about these lines M and N? Lines M and N here. So let us verify how they are. And here there are three angles made at the point of intersection of three lines. Here you consider the angles, angle 1, angle 2 and angle 3, which are at the point of intersection made by the transversal of these three lines. Now here you know that as M is parallel to L, as M is parallel to L, angle 1 must be equals to angle 2 because they are corresponding angles made by the transversal of parallel lines. Corresponding angles. And again you know that as N is parallel to L, here N is parallel to L, then again you have angle 1 is equals to angle 3. Angle 1 is equals to angle 3. Same reason you can give. They are the corresponding angles. Corresponding angles made by the transversal of the parallel lines N and L. Now, here you know that in both the relation LHS are same. Therefore, RHS must be equals. Therefore, here you have this is first one, this is second one. From first and second, you can have angle 2 is equals to angle 3. Angle 2 is equals to angle 3. Therefore, as these corresponding angles are equal, with the help of the converse axiom of corresponding angles, you can say that the lines M and N are parallel to each other. Therefore, you can say that M is parallel to N. That is, which axiom here? Converse of corresponding angle axiom. Corresponding angles axiom. So what you can see here? The lines which are parallel to the same line are parallel to each other. So you have this statement here. What is the nature of the lines parallel to the same line? Lines which are parallel to the same line are parallel to each other. So if what you can write? M parallel to L and N parallel to L, then what? M is also parallel to N. Lines M and N are parallel to the same line L. Therefore, the lines M and N are parallel to each other. So, what you concluded here? Lines which are parallel to the same line are parallel to each other.